Hi, this is Praveen. Welcome to my channel, Concept Classes. Today we are going to discuss about one of the very popular topic in physics, which is motion. So let's get started. So before we start discussing about motion, there are two very interrelated topics which must be discussed together, and that is motion and rest. So we have to understand together what is motion and what is rest. So what is motion? So motion can be defined like this. An object is said to be in motion when it changes its position along with time. An object can be said in motion when it changes its position along with time. So for an example, on a road, a moving car can be an example of motion because the moving car changes its position from one position to another. Okay? Then what is rest? Rest can be defined as an object is said to be at rest when its position does not change along with time. For example, an object lying on a table will be the example of rest because the position of that object lying on the table does not change as the time passes. Alright? After this, uh, let's discuss about types of motion. There are various types of motion though, but for the sake of this video, we will only discuss about three types of motion. The first one is rectilinear motion. What is rectilinear motion? So if an object travels in a straight path, such motion is called as rectilinear motion. For example, the car traveling on a road, someone walking on the road, a straight road, these motions are example of rectilinear motion. Next type of motion we have is oscillatory motion. When an object moves back and forth using a point of suspension, that motion is the example of oscillatory motion. For example, the pendulum of a pendulum clock is the example of oscillatory motion because the motion happens back and forth from one position and then comes back to the same position, and the motion keeps happening. Such motion is the example of oscillatory motion. Next example is the next type of motion is circular motion. As the name suggests, when the object moves on a circular path, such motion is called as circular motion. So for the sake of this video and for other upcoming videos, we will only focus our discussion on rectilinear motion. So let's discuss in detail what exactly rectilinear motion is, and we will also discuss about some various aspects of rectilinear motion, right? So rectilinear motion is also referred to as sometimes as linear motion. What is a rectilinear motion? We have already defined a rectilinear motion once, that when an object moves in a straight path, the motion can be said a rectilinear motion or linear motion. For example, here there is an object which is at position A and it starts from rest, so it has not traveled anything. And now this object starts moving from position A, then goes to position B, to C, to D, to E, and then to F. This example shows the example of, the motion which is a example of rectilinear motion. Here the object is traveling on a straight path, and this is an example of rectilinear motion. After discussing rectilinear motion, what exactly it is, we have to discuss about two important aspects of rectilinear motion. The one is distance and another one is displacement. What is distance and what is displacement? So distance. When an object moves from one position to another, the total path length traveled by the object is called distance. Distance talks about only the magnitude of the path traveled, and it does not talk about the direction. So what does it mean? This means that when an object moves on a path, whatever amount of distance that object has covered, the total length is called as distance. So when we discuss about distance, we only consider the magnitude of the path traveled, and we don't talk about the direction, and that is why distance is called as a scalar quantity. When we will discuss about displacement, then we can understand the difference between these two, what exactly distance is and what exactly displacement is. So what is displacement? The shortest path length from initial position to final position is called displacement. Displacement talks about the magnitude as well as the direction of the path, and that is why displacement is called as a vector quantity. Vector quantity, right? So scalar quantities are those physical quantities which only talk about the magnitude. Vector quantities are those physical quantities which talk about magnitude as well as the direction of the motion. So let's understand the difference between distance and displacement using this example once again. So in this example, an object travels from position A and then it goes to position, let's say it comes to position C. So it starts moving from position A and then it comes to position G, and then it again comes back to position E. So when we have to calculate the distance traveled by this object in this motion, first of all we will have to calculate the total path that he has traveled. So when he travels from A to G, he has covered 60 centimeter, and then when it comes back to E, it again covered 20 centimeter. So total distance traveled by this object will be 60 plus 20, which will be 80 centimeter. So 80 centimeter is the distance traveled by this object. But then what is displacement in this motion? So in this motion, when the object travels from position A to G and then comes back to E, the displacement will be only the difference from this position to this position. This is the initial position and this is the final position. So the displacement will be only 10 10 10 10, so it's 40. So displacement will be 40 centimeter. So in this entire motion, the distance was covered by the object is 80 centimeter and the displacement is only 40 centimeter. That is the difference between distance and displacement. We will discuss few more examples to understand the difference between distance and displacement. Let's take this example. A boy is traveling on a rectangular path, and this rectangular path has the width of 3 meter and then length of 5 meter. In this rectangular path a boy is traveling. So let's say a boy starts from position A and then travels this entire rectangular path and then comes back to position A, and then we have to calculate what is the distance covered by this boy. So when we have to calculate distance, we will add the entire path length that he has traveled. So the distance covered by this boy by traveling A and then coming back to, I mean from starting from position A and then coming back to position A will be 3 meter 3 meter 3 meter and 3 meter 5 meter 3 meter and 5 meter. So total distance covered by this boy will be 16 meter. when a boy travels from position A and then comes back to this position A, the total amount of distance covered by this boy is 16 meter. And then but what is displacement? So in this case displacement will be 0, because this boy started from position A and then it came back to position A. So change in position from initial position and final position is 0. That is why the displacement is 0, right? In the same example, let's consider this boy starts from position A and then it reaches to position C. What will be distance and what will be displacement? So uh, like here, so when the boy starts from position A and reaches to position C, the total path length that he has covered is 3 meter plus 5 meter, which is 8 meter. So the distance covered by this boy will be 8 meter. But what will be displacement? So for to find the displacement, we will have to find out the length of this diagonal, which will give the displacement of when the boy moves from position A to position C. So when we find out the length of this diagonal, this length of the diagonal will give the displacement covered by the boy when he moves from position A to position C. Let's discuss one more example. Like here in this example, let's say this rider on this bicycle starts moving from position A and then reaches to position C. So what will be the distance covered by him, the distance traveled by him? So when we have to find the distance, we will simply add this 4 meter and this 3 meter, which will be 7 meter. So the distance traveled by this boy will be 7 meter. But what will be displacement? So again, to find the displacement, we will have to find the length of this diagonal, which is 5 meter. So 5 meter will be displacement. We have one more example here. Like let's say an object traveled using a zigzag path and it reaches to position B. What will be the distance traveled by the object? So the distance will be the total path length that he has covered from this position to this position will be the distance. And when we have to calculate displacement, it will be this shortest length will give us the displacement displacement uh, covered by that object. So we got the conclusion, I think, the distance and displacement. After discussing about distance and displacement, let's discuss about again two very important aspects of motion, which is uniform motion and non-uniform motion. What is uniform motion and what is non-uniform motion? So when the object travels equal distances in equal intervals of time, the motion is said to be a uniform motion. What does it mean? So if an object travels equal amount of distance in equal interval of time, that motion is an example of uniform motion. For example, in this example, we can see an object starts from 0 and reaches to 2 meter in 10 seconds, and then it reaches to 4 meter in again 10 seconds, and then to 6 meter it again takes 10 seconds. So for every 2 meter travel, the object takes 10 seconds. So it is covering equal distance in equal interval of time. So this example is the example of a uniform motion. In uniform motion, the object covers equal amount of distance in equal interval of time. Then what is non-uniform motion? So in opposite to uniform motion, the non-uniform motion is like when an object travels unequal distances in equal intervals of time, the motion is non-uniform motion. For example, here an object starts from 0 and reaches to 4 meter in 10 seconds, and then it reaches to 6 meter in 10 seconds again, and then from 6 meter to 12 meter it reaches in 10 seconds. So the time interval is same, but the distance covered by this object is not equal in every cases. So that is why this motion is the example of non-uniform motion. When we will come to other topics of motion, when we will start discussing velocity, speed and acceleration, then we will be able to understand the difference between non-uniform motion and uniform motion in a more clear way, right? So now let us understand few examples of uniform and non-uniform motion. Here, like let's say a car travels equal distances in equal interval of time, so that motion of the car will be an example of uniform motion. And if another car B, let's say, that travels unequal distances in equal interval of time, so that is an example of non-uniform motion. Here we have one more example, like the movement of the hands of the clock. When we observe the movement of hands of a clock, either it is minute hand or hour hand, that minute hand covers equal distance always in equal interval of time. That is why the movement of hands of the clock is always an example of uniform motion. Whereas if an athlete is running on a track, he starts slowly, then he has to increase his pace after some time. So that motion is an example of non-uniform motion. We also have one more example using a table which will describe the difference between non-uniform and uniform motion. Let's say here is a table in which this is the time, and then this is the position of A, and this is the position of B. So A travels 6 meter in 5 seconds, and then again 6 meter more in again 5 seconds, so it reaches to 12 meter, and then 6 meter more in again 5 seconds. So this is the motion of A is an example of uniform motion, whereas the motion of B is an example of non-uniform motion, because it covers 3 meter in 5 seconds, and then uh, another 4 meter in another 5 seconds, and then another 12 meter in another 5 seconds. So this is covering unequal distances in equal interval of time. So this is an example of non-uniform motion, right? Similarly, we have one more example which shows here the difference between uniform motion and non-uniform motion, that is same way. Okay, so after discussing uniform motion and non-uniform motion, let's discuss about the rate of motion. Like whenever a motion is happening, we will have to calculate the distance displacement in respect to time, and that is when we have to discuss about rate of motion. What is rate of motion? So the change of position of an object per unit time is called rate of motion. The change of position of an object per unit time is called rate of motion. The physical quantities for rate of motion are speed and velocity. So when we say rate of motion, we are actually talking about speed and velocity. When we have to measure the distances or displacement traveled by any object divided by the total time that the object has taken, that gives us speed or velocity. We will further in further slides we will understand the difference between speed and velocity. So the physical quantities for rate of motion are speed and velocity. So speed is the distance per unit time and velocity is the displacement per unit time. When we calculate a rate of motion in respect to distance per unit time, that rate of motion is speed, and when we calculate the rate of motion in respect to displacement per unit time, that is velocity. So we require only the magnitude when we talk about speed. However, when we talk about velocity, we also require direction. It is already understood, because the distance is a scalar quantity, and when we discuss about distance, we don't talk about direction, we only talk about magnitude. So same way, when we talk about speed, we only talk about magnitude and we don't talk about direction. However, when we talk about velocity, we also talk about magnitude as well as direction, because velocity is displacement per unit time. So as displacement talks about direction as well, so in velocity we also talk about direction. So hence we can say speed is a scalar quantity, however velocity is a vector quantity. So in a uniform motion, velocity remains constant, and in a non-uniform motion, the velocity changes. In previous slides, we just discussed about uniform motion and non-uniform motion. So we defined uniform motion like the equal amount of distances covered in equal interval of time is uniform motion. So if an object is covering equal amount of distances in equal interval of time, that means the velocity of that object is not changing. Velocity is remaining constant. And in non-uniform motion, velocity changes every time. That is why we say in a uniform motion velocity remains constant, and in a non-uniform motion the velocity changes. Alright, so now let's talk about speed in little detail. What is speed? So we have already defined speed as the rate of motion per unit time in aspect of distance. So speed is mathematically represented as speed is equal to distance divided by time. We denote a speed by a small v, and distance using the letter small s, and time using a small t. So speed is equal to distance by time, where v is speed, s is distance, and t is time. So average speed here, I mean we are trying to say average speed, not average velocity. So average speed is equal to total distance traveled by total time taken. When we find speed, like let's say an object is traveling with a speed of 20 kilometer per hour, and then it increases its speed and travels with 30 kilometer per hour now. So what will be the average speed by that object? So we'll first of all calculate total distance traveled by that object, and then we can divide that total distance traveled by the total time taken, which will give us average speed. The SI unit of speed is meter per second, which is written as meter per second. When we calculate speed, uh, we have to write a speed using a unit. So SI unit for a speed will be meter per second, which is written as meter per second. So let's try to solve a question which will make us little more clear about speed. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So to solve this example, we can solve it this way, like, so the total distance traveled by object is 16 meter plus 16 meter, which is 32 meter. Total time taken is 4 second plus 4 second is 6 second. So when we have to find average speed, which will be total distance traveled by total time taken, that is 32 meter divided by 6 second, that is 5.33 meter per second is the average speed by this of this object. Alright, now let's discuss about velocity. What is velocity? The rate of motion with respect to direction is called velocity. We have already defined velocity in previous slide. What is velocity? Is the velocity is displacement per unit time. That is why we are saying the rate of motion with respect to direction is called velocity. Mathematically, we can write velocity is equal to displacement divided by time. And when we have to calculate average velocity, we will calculate like average velocity is equal to initial velocity plus final velocity divided by 2, which will give us average velocity, right? And we can represent average velocity like more precise way using symbols, which will be average velocity is equal to u plus v divided by 2, where u is initial velocity and v is final velocity. And SI unit of again velocity is also meter per second, which is written as which is read as meter per second. So for velocity as well, we will try to solve one example. What is the example? It says Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming one end to another and then coming back. Find speed and velocity. So there is a woman Usha. She swims in a 90-meter long pool. She covers 180 meter by covering the distance back and forth. She covers the entire length of the pool and then comes back to the same position. And so now we have to find out the speed and the velocity of Usha. So speed will be total distance covered by total time taken, which is 180 meter divided by 60 seconds, because she took 1 minute. 1 minute is equal to 60 seconds. So speed will be 180 divided by 60, that is 3 meter per second. What will be velocity? Because Usha started from a position and then she came back to the same position, that is why there is no displacement, and velocity is equal to displacement by time. Displacement is 0, so 0 by any time is 0 meter per second, so velocity is 0 meter per second. Alright, now after discussing about speed and velocity, now let's discuss about rate of change of velocity. Sometimes an object will travel and it will keep increasing or decreasing its velocity, and that is when we have to measure the change of velocity of that object. And to to measure the change of velocity of an object, we have to introduce a new physical quantity which is called as acceleration. So in a non-uniform motion, why non-uniform motion? Because in a non-uniform motion only the object will change its velocity. If the object does not change its velocity, if object is in uniform motion, in that case velocity will not change, and if the velocity will not change, there is no point of acceleration. So the rate of change of velocity, we always talk about a uniform, a non-uniform motion. So in a non-uniform motion, velocity changes with time. Change of velocity per unit time is called acceleration. So first of all we have to find out how much the change of velocity is, and then we divide that by the total time taken. That will give us the acceleration. So mathematically we can write acceleration is equal to change in velocity divided by time, where a is acceleration, here mathematically in a more precise way, using the symbols, we can write a is equal to v minus u by t, where a is equal to acceleration, u is initial velocity, v is final velocity, and t is time, right? And this will give us acceleration. SI unit of acceleration is equal to meter per second square, which is read as meter per second square. So if the velocity of the object decreases with time, the acceleration in such case will be negative. a negative acceleration is called as retardation. Yes, so let's say an object was moving with a velocity of 20 meter per second, and now it has decreased its velocity, and now it's moving with a velocity of 15 meter per second. So in that case, the object is moving with a negative acceleration, because when we will find acceleration, we will sorry, we will write v minus u by t. So v is 15 and then u is 20. It will come in negative. So that negative acceleration is called as retardation, right? So these are some of the examples which shows the acceleration. Now, example A shows a positive acceleration in which an object is uh, moving with a positive acceleration, like it's increasing its velocity with time, we can see by this chart. Whereas example C shows a negative acceleration in which the object is decreasing its velocity. So in example C, this is a retardation, right? Now let us try to solve one question on acceleration. Starting from a stationary position, a boy paddles his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in next 5 seconds. Calculate the acceleration of the bicycle in both cases. So there are two cases here. In the first case, the boy starts from a stationary position and then reaches to a velocity of 6 meter per second in 30 seconds. So in first case, the initial velocity will be 0 because the object starts from a stationary position. So initial velocity u will be 0 meter per second, final velocity is 6 meter per second, and time taken is 30 seconds. Excuse me. So to find out acceleration, which is a is equal to v minus u by t, so 6 meter per second minus 0 meter per second divided by 30 second, that is 0.2 meter per second square, is the acceleration in first case. In second case, where the boy applies brakes on his bicycle, the velocity starts decreasing. So when he applies the brake, and that point of time the velocity was 6 meter per second. So initial velocity is 6 meter per second, and after he applies the brake, the velocity decreases to 4 meter per second. So the final velocity is 4 meter per second. The time it took to change the velocity from 6 to 4 is 5 seconds. So it's 5 seconds. So in this case, acceleration is v minus u by t. This way we can find 0.4 minus 0.4 meter per second square is the acceleration, which is actually a retardation. All right. So now we will summarize this video, what we have learned so far. So we have talked about motion, how motion is different from rest. Excuse me. And then we also talked about types of motion. Like there are various types of motion: rectilinear, oscillatory, and circular. And then we discussed about distance and displacement, how distance is different from displacement, and how distance is a vector quantity and distance is a scalar quantity. Then we similarly discussed about speed and velocity, and then finally we talked about acceleration. So that was all in this video. I hope this video was informative for you, and I would like to thank you for viewing this.